So again, I have 25 slides, go a little bit over the latest in structured cabling, and it's more from a standards perspective from TIA and IEEE. And you can see the agenda that's up there on the screen. Again, we've seen a big change, really in a move now. I think a lot of folks are doing 100 gig now when they're doing spine to leaf. We're also seeing fiber channel move up to 128 gig fiber channel or 32 gig with an SFP. And we're also seeing, where you're probably familiar with some of the cabling where in Ethernet based, it might be like an MTP connector or a parallel optic transceiver that's now in the same place for fiber channel as well. So again, I'm going to start with TIA, more like the design with patch panels, IEEE, what's the latest with transceivers. And I would say, and you probably noticed this, the time it took to go from 1 gig to 10 gig took a very long time. And I think we all remember how long it took. And then we went from 10 gig to 40 gig. And we did that a lot because vendors like Cisco and Arista had a universal or a bi-directional optic that was the same price as a 10 gig. So people went to 40 gig easy because the cost was really close from 10 gig. And then now, again, we're seeing that people are going to 100 gig for any new installations, typically for a spine to leaf. And again, it's really about the price of the optic. I can say I'm in several multi-source agreement groups or MSA groups who are making new technology for optics. So instead of just 1 or 2 vendors out there trying to push a new technology, there's several of us. So there's a lot of different people pushing new technologies for the optics. And again, that's why I think speeds are going quicker. Again, a lot of people put time and money into it. If the cost comes down, you'll buy it, most likely. Even though you say, hey, I don't need 100 gig, 200 gig, or 400 gig, if the cost per port is less, you will consider it, right? So I'll show you some designs later. I want to talk a little bit about fiber channel. If you're buying fiber channel now from companies like Brocade, who has 80% market share, they're pushing a Generation 6 fiber channel speed. They also actually released Gen 7 last November. So again, I know people are saying I don't need these higher speeds, but if the time comes and you're looking and you're putting a dollar amount to everything, if you could jump to the higher speed, why would you not, right? So so some of the things, and I should give you a little background about myself. I've been doing this 21 years. I'm a data center architect for my company, not really software, more design. So I travel the country and I do design work for people building a new data center, or if they're adding new network or fiber channel switches or mainframes. So I get to see what a lot of people are doing. And typically when I'll start a design, I'll talk about 942, which I mean patch panels. Instead of doing home run jumpers, I think we both know home run jumpers are easiest. Probably some vendors would like you to do home run jumpers because there's no dB loss, or the dB loss in the link is less, and so there's less downtime or concern. But again, having patch panels makes life a lot easier. And if you can plan with patch panels and growth, it can make things a lot easier in your environment too. So when we consider about standards, 942-B, that's really, again, patch panel, hot aisle, cold aisle, different standards. Again, I think you're all familiar with that. The TIA 568.3-D, again, this has been updated in 2016. This is talked about MTP polarity, so, or MPO or MTP, which is the same type of connector. And are you guys pretty familiar with an MTP MPO? I would think that most of you are. In the standards right now, there's 3 approved polarity methods for that, is A, B, and C. Certain people do a certain one for a certain way. They might have done it a certain way forever, so they keep doing it. You'll also notice in the industry, again, being us a cable manufacturer, we're offering a new polarity method, but it's not in the standards, and it will not be in the standards in the short term because nobody can agree to put it in the standards. So what I would say about the 942 MTP, there's 2 of them that are best for an LC connector or duplex. There's one that's best for parallel or MTP type optics, but there's not one for best for both. So a lot of us big vendors, we have different ways that we present this as a solution. And again, this is vendor agnostic right here. I need to be very neutral. Again, if you want to discuss this in more detail, let me know. But I think you'll see out there different companies and all the big ones offering different solutions. And this is the reason why, to work with LCs and MTP optics. Because again, people are buying parallel transceivers now. And then the last one is the 606C, which is a labeling standard administration. And a big thing for us is when cabling goes out to an environment, whether the customer installs it or they have an installation partner, everything is labeled so they know where it goes. And again, I think you guys know you want things labeled. So if somebody says, I have a port, I need to find it, what cabinet, what rack unit, what port in that rack unit, right? You should number everything, make it easier. And again, part of that standard is too, if you decommission an optic, you unplug a server, you remove that cabling as well. And that's where having a patch panel helps, because it's a shorter cable. And again, some of these things are review, I just still like these, and I think if you see here, this can show up. This has been around for a long time, where you have an MDA, you have a patch panel, you have a patch panel, you have a patch panel. And there's been, over the past 5 or 7 years, a lot of presentations about too much dB loss, too many patch panels in a link, because to go the higher speeds, 40 and 100 gig, there's a dB loss and a distance associated with that. So if you introduce too many interconnects or connections, you're gonna blow your light budget. So the part about it is to have patch panels in a logical way, plan for growth, but don't have too many. So, this slide is a nice slide that shows the different polarity methods, and method A, B, and C, and just a little history on it. Method A came out first. This is back in the day when you probably had an electrical contractor run your cabling, and everything was straight through. So if they had a jumper, a cassette, a trunk to another cassette to a jumper, they would just have one of those jumpers do a cross, and that's where they would do the signal. Everything was straight through. And some of the really large people that have been in the data center world for a long time still use method A because they've always used it. And then came method B. In method B, you see that flip there. And that flip in method B is best for parallel transceivers. And so in the mid-2000s, there was a thought in the industry that if we want to go above 1 gig or 10 gigs, these higher speeds, we need more fibers to do it. We can't do it with just 2. So they came out with this polarity method there. There is some intellectual property or patents on 2 of the large vendors using this method, and I just won't go into that, but so there's a little bit of that makes it kind of interesting. And then we go to type C, and type C we saw pretty dominant for a long time. It was best for duplex connections. And if you remember, typically for the past 10 years, if you're doing duplex fiber, it was probably fiber channel. And most of your fiber channel switches are LC based or duplex. So again, these are the 3 that are in the standards, and really these new polarity methods that I talked to you about that we do and everybody does, it's really the best of both of those parts. We take the best, meaning that if you have jumpers on both sides are the same, the cassettes are the same, there's no alpha and beta, the trunk is a specific way. Again, we can go into more detail on that if you want to talk on the side. This is a little bit of that labeling standard, and again, when we do labeling and we typically you send cabling out, or if you have your own folks label cable, make sure to put where both ends go. And there's a standard for that. And again, this is not rocket science. It's not hard to do. But if you keep up with it, it'll really make things a lot easier. And this way you can have smart hands in there, managing things. You can send them to identify a specific port. And all these standards are for purchase from TIA. I think that one was like $288. So again, you can buy that thing online and have it downloaded. So some of the considerations on this, and again, I can just read this word for word, but I think basically, looking at the standards using patch panels, understanding the polarity options with the MTP, and then just plan to label everything, or have a labeling scheme that works best for So now going to IEEE, and the 802.3, this is the organization that's pushing out the new transceivers for Ethernet. And this things have really ramped up a lot. We've had 3 releases since 2010. And if you look at the very top, this is when we kind of jumped out of the 10 gig space. When we did that 802.3, you see the BA, and that introduced 40 and 100 gig. And 40 was going over a 12 fiber MTP, which you see at the top right there. And then you see there was an SR4 transceiver that was 100 gig that had 2 rows of 12. And that was what you did 100 gig. Those transceivers were really expensive, and not a lot of people deployed those. I mean, certain applications required them, yes. But again, that connector kind of never really took hold. And then we see in 2015 here where the BM, again, BS went to BM, and then you see there's a BS. So we're in this one that came out in 2015, and what it did is it lost this. So it was able to do 40 and 100 gig over 12 fibers. And how it is, again, there's a row of 12 there. We're doing 4 fibers send, 4 fibers received. And that's what, if you heard of terminology called base 8 or MPO 8, that means they're using 8 fibers out of that. So that is kind of really the de facto standard right now. There's several other optics that work in this space as well to do 100 gig, and I'll go into that a little bit later and give you some price points, list price points. So as of the last day of 2017, December 31st, because IEEE, the organization, said they would release this standard in 2017, but it really mostly came out in January as publishing and things like that, introduced 200 and 400 gig. And so it introduced a brand new connector, and it's this one right here at MTP16. So instead of 12, there's 16 fibers right here. You notice there's an offset key right there. So this connector does not plug in with anything here. It also introduced a single mode connector here looking with 12 fibers, right? So it's adding more fibers to run off, and now single mode's coming into the equation. So from our perspective and what we think people are gonna do and what we think is gonna be next to deploy, we don't see anybody doing a whole new backbone of MTP16. Doesn't really make a lot of sense, right? The 12 with the 8 fibers in is an SR8, seems to be dominant. Why would you rip and replace? But I do think because of this transceiver, the PSM4, again, the bottom here, I do think that a lot of customers are gonna start switching to an MTP-based connection here. Again, so this is a 200 and 400 gig connection. In the marketplace, have you ever heard of a PSM4 transceiver? It's a single mode like this right here. And again, so you can do that for 100 gig. To give you a price comparison, and so I'm gonna use Cisco because I think we're all familiar with Cisco, and I'm talking about a list price, and I'm talking about 100 gig transceivers. So from Cisco, if you buy their 40 and 100 gig dual rate BiDi, again, that takes an LC connector, it lists for $19.95. If you buy from them 100 gig SR4, and when I say SR4, I mean this, 4 send, 4 receive. Again, this is a standards-based transceiver. So again, this could plug into Palo Alto. It works with other equipment where that first bidirectional works just with Cisco, right? But it works with an LC. And then we talk about the PSM4, again like this, again from them it lists for $19.95, right? So these 3 transceivers list price are the same for 100 gig. And if this is a new application and you can choose one, I think I would like to go to single mode. Maybe it might make it might be a good idea to do that. So I think this is the reason they're saying maybe it's time to do single mode. It's the price on the optics. Some of the benefits of this as well is an SR4 in the multi-mode has a distance limitation of 100 meters on OM4 or 150 meters on OM5. But with single mode, it's 500 meters, right? So that's a pretty doggone far. And I think this PSM4, from what I understand where it came from was the Googles, the Facebooks, the Amazons, about 5 or 6 years ago, they have big data halls, obviously, right? They needed to make a connection. They really needed it over 100 meters. They didn't want to buy a 2-kilometer single mode LC optic. It was too expensive. They wanted to go 500 meters. So they went out to the Finisars and the Mellanox and said, hey guys, we need an optic to make this distance. What can you do? And that's where the PSM4 came out. So it's a lot less expensive than your 2-kilometer. Again, because I think your decision to decide what optic to use would be all based on price typically, right? If it's the same price, why wouldn't you go faster if it can work? So here's some of the dB loss. It is associated because, and again, we know when we're doing specifically multi-mode that there's a distance and a dB loss associated. And I think if you see over here, the far end over here, we're talking about here, and then again, the latest standard here, they're trying to gear everything towards 100 meters for Ethernet. And they're doing the same thing for fiber channel. So I think a rule of thumb that we consider is multi-mode 100 meters. OM5, for certain manufacturers, they'll say 150 meters. I believe IBM and Arista have in their spec and their optics that do 150 meters on OM5. I don't think Cisco shows that just yet. But again, you're getting a little extra 50 meters with that more expensive glass. I would say too that from our perspective as a manufacturer that single mode glass is cheaper than OM4 and it's a lot cheaper than OM5. So keep that in mind. And then we're jumping again. These are the new standards that just came out for the 200 and 400 gig. And I think if you see here at the bottom, this 3.3 of dB loss right there for the link, that's a heck of a lot, right? 3.3. So again, if you're doing single mode now, the benefit of giving you that 500 meter distance, it also allows you to have more interconnects. And typically an MTP can introduce like 0.2, max dBs like 0.2. So you think about if you have room for 2 dBs of loss, you're way under the window for that. So I just see a lot of advantages for single mode. Again, I know it's not for every application, but if you start crunching the numbers now on the optics and everything that goes with it, I think you'll find out that it might not be such a bad idea. So a little bit about, to sum up the 400 gig, the introduction of the new MTP16. Along with the MTP16 was an MTP32 2 rows of 16, because the speed of the going down an individual fiber now is doing 50 gigs per fiber with this latest standard. The 32 went away, and now we're on the 16. And again, this is partly looking at the latest MSA groups and what they're looking to do to jump the next speeds. And this is why I'm thinking MTP 16 will not get a foothold. It'll just go right back to the 12. It'll be come in and go. And then I think that as well that single mode will start to make a big dominant turn on this. If you listen to Arista, you know, they're a competitor of Cisco, and I think that they're both probably have a lot of the market share together. And I'm reading a lot of what they're saying, and I want to be up to date to understand what they're pushing to their customers are. So they now have a 32-port 1U switch, and it has 32 400 gig ports, and it breaks out to 128 100 gig ports. So buying ports that way from them is half the price of buying individual 100 gig ports. So why people are using 400 gig is because it makes 100 gig cheaper. So again, if you're thinking, why would I need to go this speed? It's just because it makes it less expensive. And that makes sense, right? So thinking about, okay, you're a customer, you have a traditional MTP infrastructure in, you're doing the 12 fiber MTPs, or again, you could have 24. Some people have some 24s out there, and there's some advantages for that as well. So as far as the product set now to make it work is, just make this new Y cable, where this is an MTP 16 right here, and this breaks out to 2, 8, or 12, and this would go right into your existing infrastructure. Again, not rocket science, right? So that's how you would plug a new 400 gig MTP 16 into your infrastructure. And on the back end, if it needed to be broken out to 100 gig ports, you break it out, or you can go right back to a spine switch, maybe that it is, takes the MTP 16. Again, a little bit of the discussion that we had with the multi-mode versus single mode. The costs have just really come down, and it really has come down with that PSM4. Again, you see it's the same list price from Cisco, and I think that's a pretty good indicator on that. I mentioned about single mode glass from a manufacturing perspective is less than OM4 and OM5. The new PSM4 optic, you know, brings you up to 500 meters, which in most data center spaces, that distance is good enough to go. I mean, really, heck, 100 meters is in most data center spaces, right? Unless you're large. And again, knowing too that the PSM4 and the SR4 transceivers are standards based, meaning that they will plug into other vendors' equipment, or sometimes some of these bi-directional transceivers will not do that. So I would verify that if you standardize on one over the other. I do see a lot of customers buying new switches, and again, they'll call us up and get us involved. A new spine to leaf, a new fiber channel director switch. And really the optics, they didn't really pay attention to the transceiver so much. They just really paid attention to the switch and where they wanted ports and how many ports they wanted. Considerations from the 802.3, again, I would recommend, again, this kind of goes from 942, right? Having a patch panel or break in the fiber. And if you think that you have a spine switch, or you have a fiber channel director switch, and if you have a patch panel above where that switch is with the break and the connectivity, you can have a small harness cable that can be MTP for your infrastructure. It can be LC, it can be MTP, it can be an MTP 16, it can be an MTP 8. So having a break in the fiber at that point, you can plug up any optic that we see available in the marketplace today. And then on the back side of a patch panel like that, and I'll show pictures of this later on, you have your horizontal or backbone cabling that stays in place for multiple generations, right? That's the value of structured cabling. It stays in place. You don't have to rip and replace every time. You would replace connections inside a cabinet, short jumpers. Again, comparing the cost of multi-mode versus single-mode optics on new spine and leaf deployments. And again, I think we'll see in Gen 7 where people for fiber channel will start to look more to single mode, but typically now people are using for fiber channel edge switches. And I think Brocade has like a 620 and a 630 for edge switches, and you link those back to your directors. So as far as port replication, I think there's kind of two schools of thought in cabling. One school of thought is we have this certain number of ports and we're going to put as many of them in a space as we can, and you put a cost per square footage on a connection, which is a way to do it, right? And you pack as many as you can, and then you have like these drawer system types enclosures, and you just pack them in and label everything, and that's a good way too. Another way to consider is doing port replication, and some people call it like one-to-one. And you can kind of get an idea of it here. So let's say this is a 32-port line card or a 1U switch, what have you. Again, if it's an LC, You have two 16-port couplers here. Again, 1, 16, 17 through 32, right? It's all logical one for one. Again, you can do it with its MTP, right? If it's just an MPO coupler, like say you're using Singlemode or PSM4 or an SR4 multimode. Again, you just number it. This is logically one for one. And a lot of one, if it's going to be a 36, same thing, LC or MTP. And what we're seeing as far as from the manufacturers right now, typically for Ethernet in higher speeds, is either going to be a 32 or a 36 port 1U, blade, line card, fabric, whatever you want to call it. So those are the numbers that we're seeing typically out there. Obviously, there's some switches that are less and that can be accommodated. But again, thinking of having it like this and replicating it in another place, whether it's the middle of row, end of row, what have you, it just makes it easier to manage. So here's a design here. I'm going to step around. So this is the design a customer did here. And so here's two brocade. This is the 9504s. Again, there's 4 slots here. And you can see a fabric A, a fabric B here, spine 1 or spine 2, however you want to say it. And then up here, we have an MTP coupler panel. So for this application, they had one of these line cards here with single mode. These two were multi-mode. So again, all your 32 ports are replicated here in your single mode. There's your 2 multi-mode. There's room for growth. So I'd always have room and plan for rack unit space for growth if you were to fully populate a switch. Plan for that. And then you just MTP trunk out. And so what this application did is they had some one data center room where the 100 meters distance was within that 100 meters. And a product like this is like a 0U bracket. And it's just basically an MTP coupler bracket. And IBM has been using these type of solutions for 25 years in their mainframe FICON plugins. But again, very cost effective. You can mount brackets like this on the back side of switches as well. And then you have your trunk, and then you have your jumpers here. Again, these go right into your leaf switch. And the same thing went for single mode. So here's a design for a customer. And really, we don't see people replicating leaf switches because every time you add a leaf switch, you just need to plug it into each spine. So more port replication on the spine side, not the leaf side. This is a drawing and doing some design. We've seen a lot of an increased business for Arista. They've done very well for themselves lately. And they have a plethora of options how to break ports out. Again, 10, 25, 40, 100. They're supposed to be shipping next quarter 200 and 400 gig transceivers themselves. And when I get the list price of that, I'll mention that, but I still don't have that number yet. But again, there's different ways to break it out. Again, you can imagine here if you had an LC going into an MTP, and you can go back and do a cassette and break it out. And again, I'm just trying to show the different ways to break these ports out. Most people might not break it out right at the spine. They might take these ports and replicate them out into a middle of row. Or they might have end of row patching where spine A on one side, spine B on the other. But again, LC or MTP replicated up here. And again, when we're looking at all the latest optics, what's next, what's new, again, it's an LC, it's an MTP, or an MTP single mode. Those are the 3. And here's another design that we're seeing. This is typical for us. This person is doing a middle of row, and they have both of their switches here. Again, and everything is replicated in here. And then they have these just direct connect. They could be 4 LC connectors or 2 LC connectors in a cable. So there's your leaf switches all here. And there's 2 LCs that are going to go back here and plug in 1 LC here, 1 LC here. You can have dual go back from each leaf, or you can just have single. Again, with redundancy, most people are doing a single connection back to each leaf. But again, I mean, doing this is not very expensive. It's pretty cost effective. It's structured cabling. Again, it's planning for next gen. Again, when you would switch the next leaf switch you might put in there or add another one, again, you just run another cable. You probably have seen in the past where people would put a patch panel in every cabinet. You can do that. But I think if you plan ahead, you don't need to do that. I would like for you to do that because I could make a lot more money. But I think you can plan around doing that if you want to. So we've been talking about Ethernet. And again, I think Ethernet was typically only MTP-based MPO and LC. Anything fiber channel was always LC. But now with Gen 6, they're jumping into the speed. And when you look at transceiver from our perspective is whether it's Ethernet or fiber channel, it's still an MTP. It still goes 100 meters. It's really the same thing. The technology that is making the transceiver, the optic itself, is basically the same thing. It's a different protocol, right? Because fiber channel is different than Ethernet. But as far as the distance limitations, pretty much what it can do, they're pretty much the same thing. And Gen 6, again, came out in 2015. It introduced 32 gig with an LC, but it introduced 128 gig fiber channel parallel. And when it says 128 parallel, that means MTP. So again, if you think of 100 gig SR4 that goes to 425s, 128 to 432s, it's the same thing. It's the same cable, it's the same polarity, right? There's no difference. You probably also remember when there was a big time when it was fiber channel over Ethernet, and there'll be one cabling system for everything in your data center space, right? But the technology never really took foothold. But from using fiber now, from my perspective, it is one fiber that can run everything because it's the same polarity. We're using the same transceivers and same optics. It's the same thing. Talking about Generation 6, and again, it really started shipping pretty big in 2007. For us, last year was a big year with people buying a bunch of new switches for fiber channel. And again, I'm speaking for Brocade. I think they have 80% market share plus, and they OEM a lot. And we're seeing a big move now to customers once they buy their Gen 6 fiber channel director switches, whether they're 4 or 8 blade is, they're adding new edge switches. And that's usually a G620 or G630. And there's some different ways to connect those back into your director switch. If you got any of you are looking at a Brocade upgrade, I think you'll talk to the Brocade rep, and they're really, they like the idea of having these edge switches, and it kind of makes sense, right? It's like what we're doing with spine and leaf for our network switches. Instead of having these 2 big switches and all the cabling come back, let's put the switches out in the data center floor where the connections need to be, and it helps us expand better, right? So I see the value in that. And then we're talking about, and I'm sure there's presentations here, fiber channel with NVMe. Again, and now we're starting to support that, and that's the technology that's really doing well. Again, so the latest generation, nobody's shipping, from what I understand, Gen 7 equipment yet. But again, the reason I want to talk about Gen 7 is because I'm saying, customer, if you're buying Gen 6 now, I want to know what Gen 7 looks like. So when you buy it, I want the cabling to work. And it's the same cabling, right? It's the same thing. And so it's really, I hope I'm trying to put to you that cabling is really pretty simple. I mean, you have to make some judgments in it, but as far as the transceivers that are current and next generation, we have an idea what they look like. I mentioned these MSA groups that I'm in a couple of them as well as. So if you want to see 800 gig, and be, whoa, who's going to do 800 gig, right? Well, we're already talking about it because they want to build it, so you buy it, right? We want everybody to get new equipment, and you can see the specs and standard, what it's going to look like. And I mentioned about that PSM4 single mode transceiver and that cable. 800 gig will work for that. So it's the same cabling. So if you're using single mode, you go 400 gig and go 800 gig down the road. And then we talk about the distances for multi-mode with OM4. At this point, Fiber Channel doesn't list OM5 to go to that 150 meters. We'll see if they do. But again, that 100 meters, just like we saw with the Ethernet standards, again, anything over 100, I would consider single mode. So here's the loss, and there's not a chart out for 7, but I think it's going to be exactly like this. So we saw that standard before from Ethernet, and it's the same thing. So this 1.5, this is the dB loss for the number of interconnects, LC or MTP connections, whatever that adds up to right there. Again, they're talking 100 meters, but the overall link loss is 1.86 or 1.9. Same thing for Ethernet, it's the same numbers. And really the difference between 1.9 to 1.5, that 0.4, they're allowing that for your horizontal or backbone cabling the trunk runs. So 0.4 just for cabling wherever it's going to. So again, we're saying that the specs on Fiber Channel and Ethernet are the same. So considerations on this. Again, I keep talking about the patch panels because I think that's where the benefit is. And again, having a patch panel where the director switches are really helps out things. Again, let's say if you bought a new Gen 6 Brocade chassis, there's 2 blades you can get. You can do a 48-port blade, which takes an LC connector. You can do a 64-port blade that takes 16 MTP connectors. So from what I understand from Brocade, the blade that's 48 costs the same as one that's the 64. Because again, there's 16 QSFP optics, and really we're talking about price here, right? So if you get those more connections for the same price, what would you do? You buy that 64-port blade, right? But again, it's a little different cabling, but as long as you have a break where that switch is, it doesn't matter. You can do MTP to LC, MTP to MTP. Again, I was talking a little bit of understanding the higher speeds of Gen 7, with the structured cabling. Again, from whatever you would want to do, you would just want to look at the specs and see what's next. And if somebody said, hey, how would I connect this optic in? And again, all that information's out there. You can spend days looking at it. But again, MTP, multimode, MTP12 single mode, and an LC. We're talking a little bit about replication and trying to show different hardware. Again, I mentioned that you can also take, again, as many ports as you want and put them in a small space. That's fine too. That's a great way to do it. But there's also kind of replication, one for one, maybe logical. And you see an enclosure like this. And this could be, for instance, a Brocade, let's say their new X6-8. It's got 8 48-port blades in it, or 8 64-port blades. You have an enclosure like this where the cassette looks just like the blade, and it's numbered 0 to 47 or 0 to 63, and this looks just like the blade. So when you're looking at the blade, it directly replicates what it is. So logically, people can plug in and out of it, and they understand where it's going, right? We see new enclosures out there like this. So I mentioned that Brocade has their G620, which is a 64-port switch. They have the G630s, which is double that, 128. And on that switch, they have 48 fixed SFPs, and they have 4 QFlex, or 4 QSFPs. So the 48 plus those 4 Qs break out 4 times 4 is 16. Your 48 and your 16 is your 64. So again, you can have cabling come out of that if you wanted to replicate that switch into a cross-connect cabinet or what have you. Again, your 48 would come out here, and then you would number these from your QFlex ports. Again, it's logically broken out, and then as your folks plug in and out of the switch, it's easy for them to find it. Here's some other designs for fiber channel, and here's a customer that's showing it. Again, you can see here, these are the harnesses coming out. There's your 16 MTPs right here. There's 16 MTP cables coming out. The cabling is going on the side. It's coming up here. Here's your MTP coupler panel, right? So there's your coupler, and it's kind of the number you choose here is, so this panel is 16, this panel is 16, 16, and 16. So those 4 16 couplers do 4 16 MTP blades, right? Logically, 1 for 1. And then you're taking this trunking going out wherever it's going, and again, whether you're doing a middle of row patching, end of row, a zone cabinet, what have you is, we're planning here for all these ports, for 72 ports Fabric A, 72 Fabric B, but then also we have room for double the growth. So I would plan for growth. We've seen a lot of applications, customers buying a switch, they put it in, they run connectivity to it and patch panels, or they need more ports. So in your mind, you don't have to buy the cassettes, you don't have to buy the NTP coupler panels, but at least have rack unit space or enclosure big enough for growth. And typically double is fine. Again, that's one thing good about structured cabling. It's modular. You can buy it as you need it, right? And a little bit on here, and I showed this one. I might have missed it on that last slide. It shows the dB loss. And one thing I would say too is when you do a light budget, and we're showing those numbers of 1.5 and 1.9, you're supposed to use the maximum dB loss, not typical. And we like to show both numbers, and I would ask if you're looking at a structured cabling system to ask for both numbers. Again, you see the max with the patch panels here of 0.55. We're way below that window of 1.5, but we're typically 0.38, which is way lower. And again, knowing those numbers, right, that proves what you're buying will work. And then again, when you're looking at Gen 7, look at those numbers and make sure they will work. Here's a larger application. This is a customer that bought 2 of the X6-8, the bigger chassis. So what we're showing here is, okay, one of the things that we've seen in the past, what they've done is, if you bought a Gen 4 fiber channel switch, typically these big switches would be in the same cabinet. And the reason they did that was the inner chassis link between the two would only go 3 meters. So they put them in the same cabinet. And you've probably seen data centers where there's 768 cables going into one cabinet. And it's a mess, right? And if they got a 2-foot wide cabinet, all the cabling's in the front of the switch. If you have to replace an optic or if a blade goes down, I mean, it can be a nightmare. So I would say when you're deploying switches as well, consider looking at some wider body cabinets, cable management, vertical cable managers, but also leave a space in top of your cabinet. So again, this could be room for growth, but what it'll also help is if you're going from Gen 6, let's say you go Gen 6 to Gen 7, you pop your new switch up here and you migrate off one fabric at a time. So there's no downtime. It's just planning for the next move. Instead of trying to shove all this stuff into one cabinet. And again, I'm a proponent of giving room. I think most data center managers, you guys want to pack it in there because the space is money for you guys. But if you can just give a little bit of love to it and give them a little bit more room, I think it'd be helpful. Again, you're seeing here an enclosure that replicates exactly the switch, so nobody plugs into this active port. You lock this door. It's replicated here. And then you could have your middle of row, end of row, zone, wherever you want to put these fiber channel connections, and they're replicating back into here. And so what you do is you cross connect an LC jumper to here. And the advantage of having a cross-connect cabinet is, instead of like that other drawing saying, okay, here's 6 ports and I'm gonna replicate live 6 ports here, you might not plug into all 6 live ports right there. But this way you can do 1 port at a time, right? Because this is all live here or whatever you want to be live. And then again, these would be cable back, so there might be more cabling here, you're not lit up, but the cable's run, and then you can just grab an LC jumper from here to here and grow 1 port at a time. But it costs more money, it's more cabling, but again, it is more efficient. And this is typically what we see for a mid-sized data center. Again, we're going to the dB loss, so we added another cross-connect cabinet, so there's more patching in there, another cassette module. And again, you see the max of 1.05, again, below that 1.5, and then you're typically 0.69, so again, you're good to go. So final considerations with all this, again, looking at TIA, IEEE, fibrechannel.org, again, knowing that Ethernet and fiber channel looks the same as far from a cabling perspective, right? The dB loss distances are about the same from the standards. Installing a patch panel over your core spine or directors allow the ability to connect any transceiver that we see out there. Obviously, multimode and single mode are different, so if you want to decide to do that, you can run a different cable. Calculate the link loss with decibels, again, to be below 1.5 total. Again, and the whole link loss needs to be 1.9. Plan to use cabling hardware that best replicates switches, servers, and compute equipment as a 1-to-1 ratio. Again, you can do it. I think a lot of folks do. They want to put as much cabling in a space as they can. You've seen those ultra-high dense enclosures that are out there. They do 72 ports in a 1U. I'm talking LC, where the typical high dense will do 48. So there is a difference. You do get more ports in a 1U, but I would have to say with most applications, 48 ports in a 1U seem reasonable too. And most people can get their hands in there in a 48. The 72s are door systems and things like that. But again, they do well. And then finally, I would just say, consider single mode maybe before where you didn't, and price the transceivers. And I would say too that working with a lot of the data center guys that are, the facilities guys that are actually running the new cabling, they're not talking to the network guys that are buying the equipment and the transceivers. And if you could have great communication with the SAN team, the network team, the facilities guys when new equipment's coming in, you can plan this. Easier said than done. Some of the more successful places I see, when something comes in the dock, they're ready for it. They know. They got they got all these ideas, even if it's single mode. We have a roadmap, a plan to do that. But I know it's hard when everybody's doing these separate jobs running 100 miles an hour, but if you guys could all talk, man, it would make life a lot easier as new stuff comes in. Thanks a lot for coming. I appreciate it.